Hello, hello. And here we are. I'm going to continue working on the mini cast that I started earlier. Do, 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 do. So far, here's a little test example of the code that I want to be able to write in the minicast. We have parsed the type definitions. Hello, penguin operator. And I think the next thing that I want to do is to parse the functions. And Pigorly. Hello, hello. I think I actually want to get rid of the fn keyword. So like this is a top level function versus not top level. I think like we can get rid of it. I feel like everything that is top level is just like a const. We could change that, but just for consistency with the main cast. It could be a const name equal, and then over here we have the value. And the value can be like a type, a function, or another constant, right? Right. So let's do this. Say cast mini, like this. So this is going to say unexpected top level item because this is a const. Because I changed the syntax. Hello, Hisoka. So we are going to just say that we have so we will have const. Const pattern is value, and we will only support the names here actually. So the enum struct union and struct, these things are actually going to be without the const part, and the function is going to be also without that. We are going to instead say like this, and let's make this at 2.5 for example. So this will still say unexpected top level item because in the mini cast let's process the top level items a little bit differently. Top level item. How about this? Top level item is going to be something which has name, string, it has a kind, top level, kind, and definition, which is AST. How about that? And the top level kind is enum union struct or function. We will also have the constant, I guess, maybe later. Type a def. We expect name and definition. That's not what I want, though. type definition, kind, top level, kind, root AST group, test, syntax. So we will have const name is value. Let's just parse that first, actually. So we'll go for item, which is this is like thing splitted by semicolons. If it is, so like this must always be a const, right? Expected const name is top level item, right? So we say if rule name is equal to const so in this case we say root top level item add source AST. We're going to match. No, we're going to say that definition is root children. We're going to need a name and children, right? Yeah, there we go. We have we will have top level item root AST group top level item is going to take the name and value. So name must be an identifier. Value must be value. And then later we're going to match value shape, right? If item shape is rule, then we do this. So this value shape with, yeah, let's do that. If we have okay, if value shape is rule root, then if rule name is equal to enum, then we're going to have type definition. If it's not unexpected top level item, which is going to be at the value span. Okay. So if it is an enum, then we have type a definition enum root return. We have enum with struct, we have a union. And also we will have rule name is equal to function. Then it's a function. And if it's a function, I'll just say top level items pushback item, where item is kind is function. Definition is so in this case the function itself. I'll just make this be the definition here, the whole value. For the type definition, we don't have name. Name is going to be passed to us here. So we just need the definition. Def, sure. Which means I need to pass the name here. Name, kind, definition. This is going to be item. Item is name, kind, definition. Boom, 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 boom. And this should work. Right? I'm just not... Oh, well, I mean, it's not going to work because... what we're doing next... so we're processing the type. Kind of AST. So this is not... Actually, it doesn't matter. We can like process everything. Process top level item in parallel, I guess. I mean, like the method doesn't matter. Process top level item, which is name, kind, and definition, which means that all I need is to have the item, top level item. Name, kind, definition is item. So if this is a function, then we just don't do anything for now. Wait, no, we want to do process type. Yeah, because process type wait. Or no. Yeah, process top level item requires this to be a record, right? But this is only if we have a type, right? Because types expect the curly brackets. I could also make for the types the definition. You know what? I will just take the curly brackets immediately instead of delaying that when I'm adding the source EST. Let's instead do that here. So when I have the type definition, which is basically means that it's not a function, then this is my definition. And then I said that definition is a rule with single child, which is a record rule. Yep. process. So process type doesn't exist for item and top level items. We just process top level item. So we process, and over here we pre-process, right? Pre-process and then process. Those are the two things that I need to do. Actually, I think at first I will need to actually process the types, because in order to parse the definitions of functions, I will need to do the thing, yeah. Yeah. So I don't panic here, actually. On the function, right? I want to say that. So if it's a struct, we're going to match item kind here, right? And we're going to add item name. If it's a struct, a union, or enum, which probably should just be like, you know, if it's a type, and then type has like subtypes. How about this? Top level kind is either a function or a type, which is type kind, where type kind is either enum, struct, or union. So type definition, this has the type kind, which means that the kind here is type kind. Top level item. Pushback item. Yep. So if it's a type, then when like added to the type names, then we will process top level item. Before doing that though, we need like to pre-process the top level item. Also, so we need to do the we will now ignore the types and only do the functions. Right? So in this case, I'm going to pre-process function item definition item name pre-process function is name is string, definition is just est. So this one is a to-do for now. Let me have this helpers. Expect rule with single child. Expect rule with 2 children. Expect string literal. Expect identifiers. Like those are all just helpers. Let me have AST helpers Yellow. I have entered Zen state. Nice. So compiler will just import the AST helpers here, and when we say expect something, I would say AST helpers expect instead. I don't mean to shift your bits, but your haircut is not the hottest today. What's wrong with it? Boop, 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 boom. No idea, I just wanted to a reason to use the expression shift your bits. I see. Type kind is not top level kind. That is true, because top level item is over here. So I will say like a type enum, right? A type union. Actually, you know what? Let's just say type kind. Then we'll match kind with this two things. Right, there we go. Process struct or union, and this takes the type kind. Yes. All right, I want to start parsing the function signatures. So we know which types exist by name, basically, right? And then we know the definitions of these types currently. This is what? This is not a function. What do I call it? No, I think this is called a function, right? It says unexpected top level item, but what is it? Okay, let's try this. Let's try cast parse tests mini test cast parse using the rule set source mini syntax, and we do tests mini test. Will your language be able to interface DLLs? Well, I have not needed that yet, but yeah, I guess you should be able to do everything, including interfacing DLLs. I have been working with JavaScript mostly so far. I have not compiled to like native code to C yet. I will. Const, yeah, hold on. Value is a function. So this is a function. If this is a function, unexpected top level item. Oh, because I did not return here. That's right. Like, I'm doing the returns in these cases. You discovered a love for Python recently through Python. I remember it. I used it for about 2 hours. I don't know. Didn't feel anything special. I thought you liked C++. Why do you like it? Just because it's better syntax than C++? I mean, maybe I didn't look too deep into it, but it's supposed to be basically like Python-like syntax, but C++-like semantics, kind of, I think. C-like, C++, not C++, C-like, probably. To Kast mini, there you go. Right, so now we have this data, which is not printed very nicely, but it's basically saying that we have a unit, and unit is a struct with no fields. You like C and C++, but you're finding it a chore to write a program from scratch in C every time, so I found this nice system of writing the core systems in C and interfacing them with Python. Okay. If you're writing the core, I mean, yeah, sure. If you like that, that's good. Do what you like. Dun, 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 dun. I remember not liking Python for the reason because Python is a chore to maintain it when you want to change things because of well, like these days you have the type system in Python, kind of. It kind of works, so maybe it's not that bad. And Python, I guess, is like the same. I think you have the type annotations there too, right? Python. I said Python. Python. Thank you. Based on Pyrex. Is something wrong with my internet? The stream is going well, right? Writing Python programs in pure Python. I'm just trying to remind myself what Python looks like. It looks like just like Python. The declaration required to enable type conversion for the pure Python enabled are defined in the aptxd file. cpdef int. Wait, so you have like pure Python annotated with types in a separate file? Or you can write just Python directly, right? I see. Yeah. So like in modern Python, you can just do the type annotations though in the regular Python, right? I'm wondering why they use the different syntax here. Because they use something that resembles C instead. And this project appeared earlier than the type annotations in pure Python, right? Can you combine the Python with annotations and with these annotations? So you can have like int on this side and then like int x colon int. All right, anyway. We are what I want to do is mini cast. So right now I'm just debug printing the program. Maybe we should instead like print some short information about the program, right? Let's just do, let's just do program scope mini program print. Is this going to work? So here's my stuff. I think I should call it not IR, but like, I don't know. The naming is always difficult. Implement program as module. Print is self program. Now you can watch the stream with no distractions from the job. I think we're approaching an era of language as module. Program as module, then we will have language as module. I mean, yeah. Let's see, I will output here. So when I print the program, you know what? How about we just print all of the types, right? And then we'll print all of the functions. Is that what I want? Maybe. You know what? Output is current output. Output, right? Types, right? With mode bold, and then we say for name, for key is name. Value is going to be definition in self types word map iterate output right name output right /n, right? And then we will have the same for functions functions, value, definition, and we'll print names. So let's just do this. I will see all of the types, all of the functions that I have parsed. Maybe printing the definition though should not be. There, unless we want the yeah, okay, now we have like this issue. Oh my god. Implementing as module is actually broken, right? So unless we do program T, how about this? How about we do instead print as a separate module inside of IR, right? That will work. And then this will be print program basically. So over here you missed the opportunity to make stream title Kast rewrite in C++ for April 1st. So instead of program print, I will say print program. Yeah, I'm not very good with jokes, you know. You would have fallen for it. What if I was actually doing it on the April 1st though? Just for a single day, we could be making a language in C++. I was thinking about this, but I was like, meh, I'm too lazy for like spending the entire day making a joke. Hello, Zent. Okay, look at this. So we have types, which is option, option data, option tag, unit, and we have the functions. I guess we want over here to output increase indentation, maybe, or maybe let's just output a rate a dash, you know, because it's like a list of things. Am I on Linux? I am on Nix OS, which is Linux. Yes. And I should have used Windows. Yeah. Yeah. I could. Maybe next 1st April, if I feel like it, I'll do a Windows. Does Minikast have its own logo? Well, there you go, like in the message right above you. That was like, there is Nigel's message. It has 2 icons, basically the logo for Minikast. Yeah, currently don't have the logo. But yeah, this over here is the Minikast logo. Do you guys even see it on this screen on the stream? It's over there. That's small. Logo would be the silhouette of the original logo as a simplified. I have like 2 ones. I have this one which is shown on the dark color scheme, but if we go to the light color scheme, then look at this. Oh my god, blindness. But this one is different a little bit. My eyes. I'm sorry. My eyes did hurt too. Okay, what's our function definition? We have args, result type, and body. But first, what we need to do is we need to, in the compiler, compiler state, we will store, so we have type names, and then we will also have the function signatures, right? Function types. So this is going to be a map from the name of the function to the function type, basically. And function type is function type could be in the function definition. How about this? We will have function type here. So function definition is, well, this one has name and type. Yeah, okay, fine. Kind of a different thing. Yeah, whatever. This one is going to be internal. Okay, so it's going to have args, which is a list of type names. Right? And we have a result, which is also a type name. Which currently is just a string, but maybe we will have more complicated types. So what's the best you can help right now? Tests? Yeah, sure, you can do tests. Whatever you want. What you want to work on. Tests are good, right? Yeah. For lecture parser, structural find and replace could be tested, I guess. I don't know if you can test syntax highlighting, but I guess you can, yeah, technically. Or maybe formatting can be tested. Formatting is probably, maybe, there are some issues in the formatter, but I don't know if like some of them are easy to fix. For one of the biggest one is this, when I open a bracket like this, right? So this is the empty, but if we do it like this, then it becomes that, right? Maybe like this is a little triggering. So maybe there could be some improvements in the formatter. Could be some improvements in like the read line, maybe also. Right, like up down, we say over here print hello world, but then I press up, it should do this line again or something, right? I think Control C, maybe similar to node, should like to exit press Control C again. Because normally you like type and then you want to like delete everything. That's when I just do Control C, right? I guess Control C to just clear stuff, maybe. I don't know. Whatever you feel like working on, if you want to. Just don't do something too big, I guess. Is the only thing. Okay, we have function types, which is a map from string to function type. So we want to figure out the types of functions. Type definition. Yeah, hold on. Compile. So preprocess function is where we figure out the types. So I know now all of the names of the types. So we can parse the types and check them for like existence, basically, of the types. Right? So when I say preprocess function, we say that if definition shape is rule root, then okay, this one is not the simplest one. Let's also see. I probably maybe don't need the async currently, at least. So we just have argument. The contexts. I think the minicast should not have the context system either. Get an invitation, go handle from some random person saying they want you for an interview position based on the GitHub profile. I never saw something like that. That's a scam? Maybe, I don't know. So we don't have the contexts. Wait, isn't this the same thing? Oh, this one has space, and this one doesn't have space. I see. So the result type, I think, also should not be optional. So we literally make it this. So the function type is just argument, arrow, and then the result. We call it args. And then function is just args, and then non-optional result type, and then fat arrow, and then body. Oh, actually, the formatter deletes the syntax definitions right now, Nigel. Maybe you can fix that one real quick, because I press Control S and then like this file gets deleted. Yeah, that's a good one to fix, probably. Okay, so if a rule name is equal to function, then yeah. You know what? AST helpers. Let's do this. Expect rule AST a rule is just a string, which is a name, right? And this will just give me the AST group, which is the root, right? So with return, we say if this is equal to rule name, then over here I just return the root, and over here we say diagnostics. Expected rule name. Am I already using the new formatter and highlighter? Yes, I'm just using the LSP, which is the self-hosted Kast LSP. So I don't have the type inference here, but the new highlighter formatter, that's what I use, yes. I only use the bootstrap when I'm compiling now. So we expect rule, and then we expect that to be 2 children. So yeah, this is just going to be the root, which is AST group, AST group, and child names is this. Fuck cakes, fuck cakes, fuck cakes, fuck cakes. Oh, cakes, thank you for the rate. Hello, hello. I love cakes. Oh, see? Not everyone says fuck cakes. There's T-Cap. He has Cap in his name, though, so I'm not sure if his, like... yeah. But hello everyone. How are you guys doing? How's Cake's game? How much money did he make already? Like 1 billion, or is it like 2 billions already? I wish I was making a game in C++ in the tower defense genre. But here I am making a programming language instead. No yachts for me. But you should, guys, wishlist my game. We have this game on Steam, the demo. Did you read Bevy? It was written in Bevy originally, but now it's a custom game engine in Rust. So I rewrote the game that's written in Rust, and I rewrote it in Rust, but in a different version of Rust, which doesn't use Bevy, you know? What made you do that? Rewrite this from Bevy? I don't know, I didn't like Bevy at the time where I tried it. I had a custom game engine before I tried Bevy, so you know. What the heck is KS file? It's called Kast. It's my own programming language that I'm working on. So I am right now making a programming language called minicast in Kast, because I'm trying to like self-host, but the whole language is a little bit too much work. So we're making a smaller version of my language, which I'm going to compile into, and then I'm going to compile that minicast into the other languages. Right now my language is transpiled to JavaScript, but I will like have other backends. Like I will transpile to C and eventually to LLVM and everything. But you know, for the least amount of work needed, we start with JavaScript. So I want to be able to like support multiple different backends. And so we're going to make this small language, which is like in between the high level language, which is the Kast, and the backends, which is going to be like C or JavaScript or LLVM, which we're going to compile into from this one. You're making an engine, kinda. Cannot imagine making a language. Well, it's kind of similar, right? Did you like doing it in Rust, or did you not enjoy it and that's why you're making your language now? No, I do like Rust. Rust is good. Rust is good. I didn't like Bevy. Bevy's, in short, it was, I was feeling like it, deletes the advantages of Rust and turns it back into a dynamic programming language. So that's the reason, mainly. But so it was made for a game jam like 2 years ago, I think. Or wait, hold on. How long has it been? How long ago did I make Linksider first? It was made for a game jam, and then we won the game jam, and then we started making the thing into a full game. Wait, how long ago was that? You want C++ to look like C and look like it was easy to code from an outsider. Cakes recreated Witcher 3 in Rust today was another message. Did he? All right. When was it? For some reason, everything is opening for 10 seconds, though. Why didn't I use Rye? Why would I use Rye? I can just use Rust. Why should I use 2 languages instead of 1 language? Bevy Jam number 3. 2023 April. Wait, it was exactly 3 years ago. Oh no. We have not released the game for 3 years already. How long did it take for Cakes to make his game? Was it 5 years? 4 years? We are reaching that same timeline. Although I'm not working on the game every day. I'm doing the other things. For 5 years, you're fine. All right. I mean, we're almost kind of done with the game. If we just start working on it a little, like the same amount that I'm putting into this language, we could get it released in like a couple months, I guess. You have to have a week to release. Thank you. All right. Can you guys all wishlist the game though? Because if you don't wishlist, then like there's kind of like no point of releasing it if we don't have the wishlists, you know. And you should play the demo. It is a good game. It's for smart people. You guys come from Cakes. You are smart, right? You like puzzle games and solving puzzles. You will like this game. For sure. Spent 9 hours compiling test project from SDL3 into web. Oh, nice. Did it work? What do you compile SDL3 into web with? With Emscripten? I thought like SDL2, I think SDL2 is like hard-coded into Emscripten, if I remember correctly. So does it even work with SDL3? Or you use something else? How do you do that? Or is there like something more native these days? Use SDL for windowing stuff and OpenGL for rendering. Yeah, I always use OpenGL for my game. Not SDL though. He wrote parts of his DirectX go to OpenGL, you know. Yeah, I don't think DirectX can be handled by Emscripten, so it must be OpenGL. I think. Like last time I used Emscripten. Back in the days, like 15 years ago, I used Emscripten to compile Rust to the web. Because the native WebAssembly was not existing yet. That was cool. But yeah, I don't know, like in Rust you don't need to use Emscripten anymore. In C++, I don't know. Maybe you can, like technically there is the native WebAssembly target in LLVM, right? So you probably can. But then you like need that something. You need something, because like in Rust there is some post-processing happening after the build, so like this tooling needs to be built for C++ too then, right? Or maybe that's what Emscripten is doing these days, I don't know. You need to talk to him, bro is lost. I don't know, like I will not be able to help with C++ much. I'm not a C++ developer. I'm a C++ hater. So it only works with CLang. Well, I mean, because LLVM is CLang, right? Yeah. I don't know if like the GNU compilers, GCC, Web or WASM, is that a thing yet? GCC project to add WASM target. A dedicated WebAssembly backend for GCC is actively being developed as part of the core project. As of early 2026, the backend supports basic compilation but still faces limitations in areas like exception handling, set jump, long jump, and the full debug info. Right. All right, so I'm making a programming language, guys, and this is what it looks like. And I know it's not like C++, and it may be a little bit weird if you see it for the first time, but it makes a lot of sense. Actually, trust, it's a good language that we are making here. So I am right now just trying to parse this program, right? So so this is what I'm writing is the Kast, which is like a programming language with a lot of features, but I am writing in it the minikast, which is a language which is simple instead. So we want something like maybe like a very tiny little bit higher level than C. So we have like top level functions, like over here we have the Fibonacci number, but we still want everything to be an expression inside of the functions. I think I will still want to have closures. We will want to have enums, structs, and unions. And maybe the any type, which is the void star, I guess. Then I will also maybe want to have support for native unwinding here still. Can you AST replace your cast into mini? No, because minicast doesn't do the type inference, so I will require the explicit type annotations here. But in the regular cast, I must do the inference. We can do compile time evaluation, so it's not as simple as just replacing the AST, right? When to evaluate code, run the inference, and then convert that into the minicast. You're trying to create a generator, binding generator for your language? Yeah. We will want to do that too, eventually. So far I have been writing the bindings manually. But we can. Technically there is like the possibility to do it automatically already because of the compile time and macros and everything. Unless there is bugs, and there's always bugs, so yeah. Anyway, we focus on the minicast for now. And I was doing what? Like, this is just some helpers for the AST, where we have the AST with 2 children. So I just do this. And then I just do that. Over here, I don't even do the diagnostic. And then over here, expect a single child from the group, AST group. Child name is an optional string. I don't think I need the error message here. So we just match child name. And do that, right? So we, instead of having like expect rule with single child, we first expect rule and then we expect a child, right? Which makes it, yeah. Expect, so yeah, over here, for example, right, we are processing an enum. An enum is a thing which, in this case, the variant name is written like this, with a colon followed by the variant name, which is a rule called variant. So I want to say variant, and then I want to say expect rule named variant. And then I want to expect single child with name some label. Sudo apt install cast. Unfortunately, that will not work. If you want to install it, you probably will have to use nix instead. So you like nix shell github castline cast. That's how you install it. Which you can do on Ubuntu if you have apt, I guess. You can do apt install nix first. Is nix in the packages of Ubuntu? It probably is, right? You're on Debian? I think it should be there too. Debian nix. Nix should work on any. Installing Nix on Debian allows you to use up-to-date software alongside Debian software. Does mean that Debian software is not up to date, but you can do it without breaking the system also. Imagine. You guys should use Nix. I use Nix, by the way. Yeah, there is sudo apt install Nix bin available in testing unstable. If you do that, or just do a script. No distractions. Okay. DevNinja says no distractions. Alright, we're expecting a child called label. And that child must be an identifier. There we go. Expecting rule with 2 children. So we instead expect a rule field. We expect the rule to be field definition. Then we expect 2 children which have names, which are label and type. And yep, this is my name and type. Is that it? We need to cast before GTA 6. Well, I mean, the cast is already on the screen, right? It's already here. So it's already before GTA 6, right? Unless you mean like cast 1.0 or something, which probably will not happen. Self-hosted cast. When is GTA 6 releasing? Is it in the fall? End of this year? Yeah, maybe. That's what I thought. I don't need to return here. It's not root, it's group. You don't have experience with these functional programming languages. It's not a functional programming language. It's a programming language. Nothing functional about it, except for the fact that it's functioning like any other programming language. No monads in Kast, unfortunately. No, we do have monads, but you don't have to use them. You can use it as a classic programming language. Where's my monad? We do have the monad example. Did you not? Do you not remember? Kast. Let's see. Monad. Look at this. Here's a monad. You just flat map stuff. You can have the syntax like in Haskell over here with the do notation. If you define the do notation, which we do this locally in this file, but you know. There is like, I think there is like just one issue with inference, but you don't have to use inference to work with monads, right? That syntax highlighting took a while. It initialized a lot of things. This is the old language server. It's not only doing the syntax highlighting. I can hover here and get the the full LSP things, and it only does the syntax highlighting once it processed the entire workspace, which means like it compiled everything. So it's not like because like it's done. Yeah, we need to fix that, and like in the new language server, so that, you know, the compiling happens in the background instead, and syntax highlighting just works immediately. I'm too lazy to fix it in the old LSP. Too much work in that I have to do in a camel, and I don't like it. Two children. I have to in this case. To do this and say A is T unwrap child value and B unwrap child value. Why did you write it in a camel if you don't like a camel? There's trade-offs that you have to make sometimes, right? Because Rust compiles a little too slow. But I mean, at this point, my Kast is also not compiling very fast, so yeah. C also compiles fast, but C is a different kind of a trade-off. C is a low-level language, which means that, like, instead of writing one line of code, I would have to write 100 lines of code for the simplest shit. So I don't want to do that. That is why you use Python with DLLs written in C. Yeah, I wouldn't want to write Python either, though, like I said earlier. Python only, like, in my opinion, works if you write something and then you, like, put it into the trash and you never come back to it and you never need to maintain your code. Then Python works. But if you need to maintain it, that's like the worst language than any other language. Well, maybe not any, right? Like JavaScript is probably all like on the same level. Compiler. Top level items, type names, program. All right, because I forgot to initialize in my state. Now we have the function types. Ord map new. Your language breadth is not very wide. Maybe you should explore what I've seen in Python. Well, I mean, at the same time, the less you know, the happier you are, you know? The ignorance is bliss or something. So if you're happy with what you are using, just keep being happy, you know? Like I said, I could have been making a game and made billions like cakes, but instead here I am making a programming language because the other programming languages suck. Right? Like I could just be happy instead. and have released a game, right? Type def spectral with single child. Definition is definition expect a rule record, expect a single child with no name. Am I going to rewrite my game in Kast? I don't know. I will definitely write other games in Kast though. That would be the goal. I have already made 2 simple games for game jam, one just as a test and one for a game jam with Kast. But to make something big, I need to work on the performance. Other games, well, I mean, rewriting Linksider in Kast would be fun for sure. Is that what you're talking about, Nordcell? That's what we should do instead? No, you shouldn't do that. Are you sure? I mean, obviously the game becomes better if you rewrite it in a better programming language, right? Right? If you use a better game engine, your game becomes better. Oh, everyone knows that. Alright, these compilation times are okay. I can just drink a little bit of tea while I'm waiting. Alright, it compiled. How's your game working out, Nerdcell? You were going to release soon, right? I think. When is it releasing? In summer? Okay, I didn't do much. I was just like refactoring some things. Just moved code around. Okay, we basically did a 1.5 hour of doing nothing. All right. So now let's do something, right? And now the next, so we just know the names of the types and the functions we don't know anything about. So the compiler, we want to pre-process function, and over here, right, we have the function. Yeah, that's what I was writing, right? Like I was saying that let's definition is definition AST helpers expect this to be the rule, which is function, right? And then we want to have the args, result type, and body, which means that we need now AST helpers expect 3 children, right? With names, which is args, result type, and body. AST. Dot child names. No, not dot. Let's just say name 1, name 2, because there is no way I have the unnamed with 3, right? Yeah, so we don't match this. We don't do that. Why am I building my own language? Why not? Why do we do anything ever? Because it's fun, right? And because I have this idea of a language which is better than the existing languages. Are you not entertained? ABC name 1, name 2. Let's just call it ABC. A, B, C. That's definitely better name than name 1, name 2, and name 3, right? Isn't everyone who wrote a new language had the same idea? No, I don't think so. Like, I think that like especially the languages that emerge recently and become, I don't know. Not what I want to say, right? Like, there is a lot of languages that instead try to focus on the beginner programmers, right? Like, so like, what does it mean to be a better language than the other language, right? Better at what is the question. And for some reason, a lot of programming languages, they focus the beginner programmers, which, I mean, kind of makes sense, right? Because most people are beginners or something, I think, right? Most people don't want to learn too much. They just want to learn the minimal amount and, like, do the stuff or something. Right? So instead of having a powerful language, you have a simple language instead. You want the language to be boring, simple. So why? Why do you want it to be boring, simple? Do you want your code, like assembly is a boring, simple language, for example, right? Or is that like too boring for you, for your taste, right? There is like a certain like complexity that you need. So assembly is too boring, but like what, like Haskell is too complicated. Well, I mean, C++ is more complicated than Haskell, but so like, also, what does it mean to be a simple language? Doesn't do magics. What's a magic? Because in my opinion, Go does a lot of magic compared to some other languages. What is the definition of magic? Like, I don't know, like the way interfaces work, in my opinion, is magic. Like, you just define type in one place, you define you define the interface in one place, you define the struct in one place. They are absolutely not connected, but the struct implements the interface for no reason, because magic, called duck typing. Like, I see that as being magic. What do you think is magic in other languages? It's magic that also can lead to errors, to bad errors. Other than that, it seems okay. Well, I mean, if you're happy with it, sure. Like, in my opinion, it's too simple of a language. C++ STL has magic errors. Yeah, C++ is definitely magic. I do agree with that. If we compare Go and C++, then sure, Go is better. But then again, better at what, right? Like less magic, sure. Sometimes you want performance. Also, in that case, C++ would be better, I guess. Rust has box to print error. You have to go through so much pain. I have not experienced the pain that you are talking about. And what does it have to do with box? What do the errors have to do with boxes? I have written a lot of Rust. I don't know what you're talking about. Errors are wrapped in some bullshit all the time, isn't it? I don't know. Are errors wrapped in some bullshit? Errors are just values, just like in Go, technically, right? You can do a boxed in error, but I don't think that's what's happening all the time, no. Well, I mean, there is something similar to that, maybe, that's called anyhow, or like the alternatives of that, which allow you to, like, not handle the errors, but that's not idiomatic Rust anyway. It's common in app code, boxed in error. Yeah, maybe. But but even then, what's the problem with that? Like, it's too verbose. Just have a type alias, I guess. Also, you can always just panic instead. Complaining about verbosity there, though, would be weird if you're coming from Go, where you just do if error is not nil all the time. Anyhow feels heavy, usually just default to string. You cannot, like, but then you need to convert existing errors to string, right? So, because with anyhow, you can just use the question mark to, like, pass the errors higher up the stack. But question mark doesn't work if you return the error, which is string. I don't know. I mean, well, I mean, it depends on what you are writing. Like when I'm making a game, I'm just panicking all the time because I don't want to handle the errors that are happening most of the time. Box turned you off while you was learning Rust. Yeah, I don't know. I mean, yeah, I can open the code for the link cider. There is no boxes. Do I even have like a lot of boxes? Wait, I'm in the wrong directory. I had to go to link cider. Box. I mean, yeah, I do have some boxes. Well, I mean, okay, my code is a little bit cursed actually. We use actually this. async functions and box din async stuff. Yeah, I mean, this is not the very cursed actually, but there's probably let's see, maybe this over here: pin box din future output box din gang async state active state plus some couple of lifetimes. Yeah, maybe this could be the I mean, technically there is an alias for a pin box din future already. I'm just not using it for some reason. Anyway, those things that are in Rust, they are there for a reason, right? So it is a trade-off too, right? Sometimes, like, it gives you lower level control than Golang, which is why the box is there and all of these things. So, like, I imagine that Kast is going to evolve also, because, like, right now it is relatively simple, where, like, for example, I'm storing my AST, where my children is just other ASTs, but you cannot do that in Rust, right? Because if you do the recursive data structure, you need to get rid of the interaction, because otherwise you would have the infinitely sized type, right? So you need to put a box somewhere or another indirection, a pointer, a reference, and replace it with an index, put it into arena, these kind of things, you know. But I don't know. I don't mind it much. Sure, like, I'm spending less time right now to spend the code, but I feel like it doesn't matter. Like, you learn to not notice these things, I think, when writing Rust. Maybe. Can we have a language which does not make this trade-off? Though, that's a question, right? You hate the generics in Go. Yes. Understandable. Understandable. But, like, the reason they are like that is because of this idea of the simple language also. They originally the developers of Go, they were resisting the ideas of having the generics in the language at all, because, like, the simpler language, right? Like you said it yourself, you want your language to be boring and, like, boring simple, right? Just get rid of generics, it becomes even more boring and even more simple, right? But even Go people realize that that's not the way, and they added it in, right? Or do you mean you hate that they exist? Yeah, designed badly, yeah. Yeah, but the reason they are designed badly is because of the this, like, concept of the simple language. So I don't like the idea of the simplicity of a language being the most important thing. It leads to bad design decisions, like the ones you see in Go there. That's just my point of view, though. I want instead to be something that is not necessarily simple, but is easy to use, because that is a big difference. Expect 3 children, args, result, type, and body. Okay, so now we want to parse the type. So arguments, we need to, okay. Let args be We need to figure out the type. So I will need to like parse type, a result type. Result type is parse type, result type. For the arguments are like named, so we want say arg types is, let's just do this, for arg in args is the iterate list. Binary rule name is comma, trailing or leading rule name is trailing comma. You had to write function for int and float. This was your only complaint about the language. It depends on what you're writing also, right? Like, but I don't know. Also I guess in the way you're writing code, like maybe, I don't know. I feel like, so like generic is just this simple example of being able to abstract over things, right? You don't want to repeat yourself. That's why we were complaining that you had to write a function for int and float, and that function was like very simple. You copy pasted it and it was still very short. But sometimes you want to abstract over more complex things, and then even more complex things, and even more complex things. And if you don't have the language that allows you to do that, then you lead to huge copy pasta. Or I don't know, sometimes instead of the copy pasta you do like type erasure, for example, is another option, right? Like instead of writing a function for int and float, you could have had a function that takes an empty interface. Then you could pass anything to the function, right? The empty interface trick is used in a bunch of places in Go, I think. I don't know how much, but I've seen it. You're fine with huge copy pasta. You dislike interface because compiler catch error and it's a runtime? Yes, exactly. That's why I don't like it, right? We want to be able to catch the errors as early as possible, but so interface moves your error to the runtime, but it reduces the boilerplate, right? But what you could have instead had in a language is like a little more complicated, a little more complex type system, which doesn't have to make the compromise of copy pasta versus runtime errors. You could still have the compile time error without the boilerplate, right? Okay, and then we have the type ascription, I believe. Syntax, type ascribe. Right, this one must be type ascribed, so this has a name and type, right? Which is arg is the helpers expect a rule called type ascribe, and then expect two children with names, expression, and type. Something like this. Number, interface, int, or float is enough for Go. Well, it's enough until it is not enough. So, yeah. It's enough for some people, and it's barely enough. It barely solves anything for others. So, yeah. Imagine writing a linear algebra library. See, like, there are also languages that solve this in a different way, like, where you, instead of allowing to be, like, generic enough to be able to write a linear algebra library, you can just make the linear algebra library as part of the core of the language. You know? Then, like... You know, see, and then problem solved. Easy. Focus on the work. Yeah, I'm barely doing anything, right? Okay. Stacks is not possible with HKT or GAT or complex factors, but that's complicated. Yeah, but also I feel like the complications there are because of the limitations of Rust, because like Rust needs something else to reduce that complexity from your code. Macros would have been cool to have in Go. Well, but that's adding complexity. That's a lot of complexity, actually, I guess. So you no longer want this simple and boring language. You actually want more power. It's just like the powers that you want, and not all the powers that other people want too. Right? So you only want some specific things because you have not hit the other, like, bigger things maybe that you didn't realize that you wanted yet. Imagine how minicast might feel right now, so neglected. No, we're making, like, I've written, like, see, 3 minutes ago I've written a piece of code, right? And this over here is also 3 minutes ago. Okay. So we have type, right? So we have arg types, push back the type. So the type over here is the AST, and I want to convert that into saying that type is parse type type. So we have archetypes, we have result type, and now I'm going to say that state context, current context, function types, add name function type, right? Where function type is result type, args is archetypes, right? There you go. So now we will say now we have the types. I just need to know how to parse a type. Parse type is a function that takes AST and returns a type name, which for now is just a single string. So for now it is going, let's start with very simple thing, which is going to say AST expect identifier. and this is the name of the type, and we return the name. Well, this will be changed though into some other thing later. And that's also when I print the program. Oh wait, this is just the type, so it doesn't really matter, right? How about I print it when preprocessing here for like logging, you know? We say log import log info we will say function, and then we'll write the function's name, opening bracket, colon, closing bracket, arrow, print type name, function type result. For index argument type and function type args, iterate, enumerate, if I is not 0, then write a comma, print type name, argument type, Alright, just write the name here. Okay, let's build. So I'm supposed to see all of the types of the function that I have defined in this file. In theory. This over here is a type which is not a single identifier, by the way, so this is not going to work. Right? I should be able to have should we always allow require an alias for all of the types? We might always require an alias actually for simplicity. Do I always want to have the aliases for simplicity here? But how do I write an alias? Alias is still like this. So I think I will have to do something. Expect three children is not there. Hold on. AST helpers. It's called expect 2 children again. This should be an error when I have 2 things in a module which are called the same. But it's not currently, it's okay. Did I forget this? Create list. This doesn't work with a trailing. Comma. Still did not fix that. That's okay. Wait, does this work even? I think this also doesn't work. Right. Yeah, this doesn't work with a pipe currently. Args. Let's do that instead. Then I have the trailing comma. In order to fix that, by the way, we need to have like two different like kinds of like macros which expand early and expand late or something. I'm not sure. Is there like a thing like that in Rust? Rust macros expanding early versus late? Or like in other languages with macros, like in Lisp? Rust macros operate on expanding code at compile time before type checking, primarily a lazy native fashion, though some built-ins use eager early expansion. Late expansion allow macros to access context, while early expansion resolves arguments first. So this expands bar first, but yeah. But sometimes you want. So like the problem is that the pipe operator is defined as a macro, and like it takes something as an argument which we need to like basically expand the insides before like doing that kind of thing. And in Rust you cannot like specify this. I think in Rust it's hard coded for certain built-ins. That's like literally how it's done. So this is the magic, and we want to like be able to solve this somehow, right? What about Lisp macros? Because Lisp is the language that's mostly known for macros, right? Lisp macros transform code before evaluation with expansion timing, dictating performance and behavior. Early expansion. Why aren't Lisp macros eagerly expanded by default? Is it games time? What games? We don't play games here. We don't make games here. We're making programming languages here. All right. Like that's like the question that I have not thought about much, though. Why aren't these macros eagerly expanded by default? Say I have macros foo and bar, and I write foo bar. My understanding that most Lisps foo is going to be given bar, not whatever bar would have expanded to, right? So like this is the choice, right? So if foo is a macro, what's the argument to foo? Is it the bar or is it the result of expanding bar, right? And that's the question. Some Lisps have something like local expand, where the implementation of foo can explicitly request the expansion of its arguments before continuing. So like so you have this, but then you can local expand that if needed, right? When you're traversing the tree, you can choose to expand something when you're writing a macro. Yeah, I guess that could be a solution. Local expand. All right, anyway, back to minicast. Optional string is not string. Because trailing comma is optional. We need to say some. Mutable array list is not array list. Of course. And that's it. I think. That was not it. Function types. Similarly, we need mutable reference. Expected type ascribe over here. Oh, wait. I should have requested the parentheses first, right? Yeah. When I'm pre-processing a function, the arguments, right? We still need to say that arguments is arguments. Expect a rule, which is scope. That's the rule of the parentheses. And then we say expect a single child with no name. Is it still called scope? Yeah, it's called scope. Okay, good. I agree that abstraction is a good feature, but like everything, it should be used carefully. Yes, of course. With great power comes great responsibility. As some wise person said once, you know? Why am I not checking out stuff? I'm just opening the thing. Wait, Plantile on Steam? What do you mean Plantile on Steam? Look at this, Davey and Nerdcell. Davey literally doesn't want to work on Linksider. He's like making a game with Nerdcell instead. Now, Linksider is never going to be released. What the fuck? Ah. You thought stream was buffering? No. It's just my brain is buffering. Hold on. Well, I mean, I was trying to log into Steam in the browser and like my internet is buffering instead. What happens if I like open the local Steam? I don't know. Like every internet connection takes 1 billion seconds or something. It seems. Okay. I'll figure that out after stream, I guess. Stream seems to be working. Also, like also on the phone it's fine. Wait, it's a Linux issue. Guys, it's a Linux. Always blame Linux. Was I doing something? Unwrapped none? Oh no, where did I unwrap none? No. If MKS is mini Kast, is MGS mini JavaScript? Yeah. No, it's a JavaScript module, I guess. I think. Okay, this like generated JavaScript is not very readable. Method text document signature help is not supported by any of the Lang servers registered for the current buffer. Well, if you are doing it in the self-cast repository, then yeah. Because the self-hosted cast doesn't do the signature help. Also, I mean, the old cast also did not do the signature help, actually. Yeah. Yeah, we don't do the signature help, you just hover instead. I never implemented it. Right, where is this code? Hold on, so I am doing the iteration. Paramage non-exhaustive, this is... Maybe this over here, self-host cast AST 250. Line 250 is over here. So this pattern match. So we are inside over here somewhere. Well, I mean, obviously, it is obvious. Oh, wait. No, wait, hold on. Wait, what? Process top level item. Yeah. Wait a second. Why am I seeing that code then? This is probably just the unwrap. Right? Variable, this is context that. This is the ID of the context. So it's context.handle. Because this is a panic. Okay, this is a panic. That makes sense. Right? This is me calling panic. So this is this is tag. Is this similar? Right. So if we are none, so this is if we are none, we're panicking. So this is the unwrap. Maybe I could like generate some comments or something in my JavaScript so that it's like easier to understand. So we're calling option unwrap on this argument, which is this first and b, some function which is called with a first and with a b. What's a b? It's child names 1. Oh, wait a second. Is it in my syntax? What are we doing? Function. Do I have groups? No, we don't. Do I have type ascribe? Expression type. Okay. Okay, hold on. I know how to... It's happening like over here, right? We are doing the option unwrap in these cases. So this is a child that doesn't exist, basically. I want to look specifically for tuple get named into option unwrap, right? Yes. So like these three, that one, that one, that one. Get named. Like I want to get named without like, what if we just don't do what if we just have in the tuple the way to tuple. You know, we have get unnamed, which returns an option. Like I want something similar that doesn't return option and instead like panics with a better error message. Holographic. Right? Like this is another trade-off, I think. That sometimes it makes sense to return an optional value, and then sometimes it makes sense to throw instead. So should this be called get opt instead? And the regular one would be a panicking one. Can I somehow do it without like so imagine if we have a language, right? You want to just write, like let's say that you're indexing an array, right? you still want to just write code like array at index I, right? But this thing can get you out of bounds, right? So what do you do what do you do here? Well, this would like throw an exception or something similar to that. You would say try. So the current idea would be that when you say just try like this basically converts this into an option or a result, rather, right? So so similar to that, over here we're basically like indexing into a member. This might as well be the indexing operator anyway, right? But it doesn't really matter. So we say like tuple, you know, get at like 2, like this, and this thing can fail. Sometimes you want to have an option instead. You would say like try, like that maybe. So the errors would be type checked, but so I mean this way would not need to duplicate the methods. Right? Whether we want to return an option or show a nice error. Which we can catch anywhere we want. But for now, let me just duplicate. Instead of doing the optional, we just return this thing directly, right? There we go. And over here, we instead of returning this, we're going to say over here panic. Tuple index out of range. And over here we say tuple doesn't have a field escape time. Okay, and right now we're now we say tuple get. So in ASD helpers we just want that. Over here we also unwrap. So this would just give me the better message currently. If I do this instead. Dun, dun. Over here though, this is optional, so this should be get opt. Over here I'm unwrapping, so I just want the regular stuff. Okay, and I think that's it. So we'll know the precise error now. Also, I should like somehow have the proper stack trace. Well, technically we do have the stack trace because we have the source map. Over here, this one is detected as ether, right? Because and that is detected as ether because of the source map, even though this is not that, right? So maybe this should not be ether, but like something more precise. We lose like the full name, just a short name here, and all of these also, like one of these is, well, this one is panic, right? So we know that this is panic, but that's because it's in the runtime, right? Yeah. All right, anyway. So tuple doesn't have field tie, there you go. All of this time, it's because this is called type, not tie, because like type being a keyword makes us sometimes shorten the names, and it is kind of meh, but okay. Okay, there you go. Function add is int into boolean. Wait, what is it into boolean? Because that's what's written here, right? Int sub is not boolean, but int, right? Okay, so we have something. And then over here we expected an identifier, but this is actually a function type, right? Which means that we want in minikast to support more complicated types, right? So type name is how do we name a type, and some of the types are not having a name, right? Like specific function type. So this is going to be actually an enum, I guess, right? So we so the type name is either it's either a named type which has a name which is string, or it is a function type which is a function type and this is the function type which is arguments and result, and then we could have like some other primitive types like a reference and other things, right? So when we print a type name, we are going to actually match self with, if it's named name, then we just write the name, and if it is function type, then we print function type. and function type is self function type, and this is what I was doing in the compiler directly here. When I pre-process function, this is it, right? So we say colon colon, and then I just say print function type. So when I print function type, we do this. Where we open the round bracket, then print the types with a comma, and then arrow, and then result. Okay. And then when I say over here parse the function type, parse type. So this is going to be why are you making your own language? Hello, Shiro745. Because I can. Because why not? Because it's interesting and fun and addicting. Someone should make a compilation of me answering the question every time. Okay, we need to come up with like some stupid answers then. Because every language is trash. And this is going to be the only true king of programming languages. So we match AST shape rule root. Token. This can return the name. In that case, we don't do anything. I think new programmers ask that question. I don't know. I mean, it can be not necessarily. You maybe like different people make languages for different reasons. Actually, I don't know. Right. I mean, technically, like languages like Rust, for example, was made to fix Firefox because maintaining a code base in C++ was not like working out, I guess, for Mozilla or something, right? That's why they created Rust. I am making it because what? Because we can improve on Rust. I don't know. I mean, yeah, it's mostly just because it's fun. And yeah, but it's also because I was trying to learn other programming languages instead of making my own programming language. Before that, I've tried a bunch of languages, and like when you try a bunch, you can like try to imagine what happens if you like combine this feature from this language, this feature from this language, right? And then you have the idea of a language that could be a better language. And so then you just start building it one day. But JavaScript already exists. That's a valid point. That's a valid point. That's another point. I mean, why we should do Rust? Why we should do Kast? I guess. JavaScript. Even you don't write JavaScript, Athano. Even you. Yeah. JavaScript is an awful language, I'm sorry. Rude. We love JavaScript. We love every language. Yeah, if not JavaScript, nothing would have existed. If not C, nothing would have existed. Right? Boom, 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 boom. Let args be. Let args. You're going to become a Go Andy now anyway? Same. I'm transparent to JavaScript currently, but my plan is to go next. Yes. What next, Athana? And then we go to C, right? Oh, you already did C though, right? Why did you stop C? header files. It's like basically the TypeScript definition files. Do you not never write that in TypeScript? Well, you only need the TypeScript definitions if you are making bindings for the JavaScript, right? Yeah. I feel like sometimes it is useful to see like the overview of your API, basically, right? Without also like over here, for example, right? I'm specifying what a compiler is, right? So I want to know that there is a compile function, a parse type function, a preprocess function, and stuff, right? So technically, sometimes the headers can be nice to have. Although I could just fold like I did, I guess. RGSTs. Function args result. Let result parse type result for arg AST in argsts array list into enter. We args push back parse type argast. Okay, so this should work. Now we can parse the function types too. No, I cannot, because array list is not AST. Over here, argast. Oh, because this is an AST, right. This is an AST, and I need to and say over here AST iterate list still. What's your OS? I am French. My OS is Nix OS, by the way. Hello, welcome. Use Linux Debian. Nice. That's also a Linux. TypeShape unit is not this. Did I do a semicolon somewhere on accident? Oh, over here. Yeah, I actually did. Yeah. So like over here, if nothing matched, right? Because over here I return, over here I return. But if not, then then this is not the correct, right? So we will report the diagnostic. When the parse type, we're over here, we create the diagnostics as expected a type. There we go. And span is AST span. All right, the progress is slow, but it's happening. It's happening. Type name is not name or function. Wait, what? What is it? Type name is... Oh, it's called names, not name. Return named. Function type is not there. Print function because it's function type there. And we also a reference for printing. Okay. This is the final change, right? Everything is going to compile finally. And this took me like half an hour or something to parse the function type. Oh, and it's still not compiling. What is this? Name is not type name. No. Type. Yeah, because over here, type, this should be like named, right? Because I expect an identifier. But no, process. Yeah, because when we're processing struct or union, we also need to like parse. Yeah, this is like type. Type is parse type. Right? Yeah. And when I parse type, I can also like check the types for existence also, by the way, immediately. Technically. Well, I mean, let's not do it to do. Let's like literally do it. Kast mini. Okay, there we go. So yeah, see, I have parsed everything that I have in my test file at least. It seems like this printing is a little bit wrong. Oh wait, no, it's not wrong. It's because like this has a single argument. Is that how I write it there too? Syntax in the test. Right, like over here I don't do the parentheses because it's a single argument. I think I might want to require parentheses here just for simplicity, for like everything to be uniform. Right? So it's a function type and arguments. We'll also say that arg asts is arg asts est helpers expect rules The helpers expect a single child. This is what I want. What would be a reason for you to find a different Linux distro? Curiosity? It's same as trying a different programming language, right? Why would you do that? Why do people create new Linux distributions if there is already NixOS existing? Or Arch? Or Debian? I guess, in your case. So I want to check that this name exists here when we are referring to a name, because we already know all of the names, right? So we'll say that current context type names contains the name so if not, then we say that name is not found. Type name not found. And this will be like token span, sure. This could just report without unwinding technically, although what would I do if the name is not existing? I'll just report. So now it says that type int32 not found over here, right? Because we have not specified what is an int32. So, and this is also a question. How do we define what is an int32? I don't really want to have built-in types in minikast, I think. Same how we don't have it in Kast. So we should say that int32 is like a type. So this would be just so this actually is a type alias. And we want to have the type aliases to what? So the int32 would. Well, I mean, actually, for the for this one, do I not just do like opaque type actually? Like we don't know what it is. We just know that it exists on the target platform, and that's it. Right? And this is how we define the operation that exists on the target platform. which depends on this. Yeah. So we need to have the opaque type. So I think the opaque type can only be the new typed, right? So, which means that I think that when I have the type names, we will have the types. And that should be opaque. Wait, hold on. It's not opaque though, right? Actually, like, the reason I could do opaque types before is because I was transparent to JavaScript. We just have the names of the types. When I'm compiling to C, I would still have to name the type in the target thing, right? So it's opaque type, but I need to give it a name in the target platform, I guess. Still. So we have type definition, right? Well, I mean, I do have the type definition opaque, right? It's just compiling that to a typed language is weird. Unless we make opaque be the void star, which I don't think I want. Because everything is a void star then, right? Because we don't... Yeah. Yeah, I want some other mechanism, but... we'll get to it. Let's for now say that I want the opaque type. So in the syntax, we say it's called opaque type, right? And when we have top level item, so I want to have a type, kind. So we will have an opaque type after all. Opaque type. What keyword do you have? A regular QWERTY keyboard. QWERTY. The 10 keyless. It's Steel Series Apex TKL3, I think, is the name. So if we have opaque type, we have name. Kind is type opaque. And definition doesn't matter here, so I can just do the value. Okay. So if we have an opaque type, process enum. Well, there is nothing to process in this case. Let's just inline it here. So context context program types. We add name to be the type which is opaque. Opaque enum union struct function. And by the way, this is duplicated now, right? We have the function type. Wait, we have a type definition, which is a function. I mean, this is just an alias to a type name, right? In this case, like this is the new types, and the other things are the aliases also, right? So we could have an alias to a type name, which means that the type name should probably just be called type, and this is the type definition. NeoVim before 0.10.0 didn't even have a Vim LSP log, which is shameful. Did you see the news where the NeoVim is going to have the native multi-cursor in 0.13? Who cares? You're stuck on 0.9 on Ubuntu. You can just install Nix on your Ubuntu and just do Nix, and you just install the NeoVim with Nix, and you'll get the latest version, whatever version you want. You've never figured out Nix-env? I don't think it should be done with a Nix-env. I mean, you can do it with a Nix-env, but I would probably do it with the home manager instead. Like, you can use the home manager with Nix on any distribution, and then you, like... It's like a mini NixOS, basically. Which would install this only, like, for your user, but it's okay, I think. I guess. I never used Nix-env. Maybe Nix-env is yeah. You only need it for your user. Yeah. Seems like a difficult process. I don't know. I feel like it's like you're already using Flakes. It's very similar, right? Well, I mean, you're using like you just define like this is the package that I want, this is the package that I want, this is the package that I want, that's the package that I want, right? And then that I get it from over there. And we have a lock file which also locks the commit. And that's it. I think with Nix-env it's like storing the log file somewhere in the system, so you don't care about that even. And you just have your configuration, which if you don't use Flakes, it is going to be even simpler, I guess. Or is Nix-env like the imperative way of using Nix-env? I never used that. Can you literally use NeoVim from inside the Nix store after Nix developing once? Yeah, you can. You can also say like Nix run. You can literally do this, right? You can say this: Nix run Nix packages NeoVim, and it is just going to download it for you. I mean, like you want to probably this to be fixed to a specific version, right? Because right now it's like trying to update it basically to the latest one. You can specify in this. Yeah, I have like a problem with my internet currently though. But you can like specify the commit here and everything. But yeah, you probably don't want it to like download everything every time you run, so you want it to be either available to you or do something, you know. Which is what Nick's Envy is for, I suppose. Int 32 is not found. Yeah, so now it's going to be found, right? We are just going to say that int 32 is opaque type. We're going to say that boolean is opaque type. What else do we have? We have type info. And we have string. Option tag. This is just me playing around with the things, though. Let me get rid of that. We also have unit. This is an empty struct. Right, yeah, so this it says that everything is found. Okay, so now that we know the types of all of the functions, and we know all of the types that exist, right? Now we just need to support a couple of expressions, most importantly the native expression. And once we have that, we can start compiling this to some actual like target definition, and we can start playing around with the minicast, right? So what do we need? We need we need expressions basically, right? Because that's the bodies of the function. That's everything that is left, I suppose. So we have the this. I don't even do the variables yet in this code, right? So we don't need a let. I don't see any semicolons. No, there is a semicolon over here, so that's okay. We can do a semicolon. Bum, 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 bum. Let's see. So we need a statement. We need a apply function. We need a scope. We need if. And we need native. Like, these are the only expressions that are available in this code. For hello world, we literally just need statement and apply. We can start with that and then start compiling to JavaScript to print the hello world. I need the string literals though still, right? So I kind of like this string type should kind of be known to the type system. NeoVim 012, and it's double pressing some keys. What's my NeoVim version currently? I think I didn't update yet. Yeah, I'm still on 011 because I haven't updated my system in a while. But yeah, I don't know. Parsing function signatures minicast. I don't know if it's your issue or NeoVim issue. I don't know. I mean, if you're using the one from Nix, you could... Well, I mean, if the issue exists, yeah, you could search the issues, I guess. Or either on the Nix packages or on the NeoVim itself. Okay, so we want the functions to be compiled, right? Which means that we process compiler. We need to process the function over here, right? So we need to process function. Name definition. Process function. Name string definition AST. So I kind of need to parse the definition again, right? Unless I store this somewhere. It's okay. Let's just say that we have the definition. We expect it to be the function. We have args result type body. We don't care about the result. I mean, it's okay. I just care about the body is what I mean, right? So we say expect rule function, yeah, like this. Children tuple get named body. AST unwrap child value, right? Then like the body is the only thing that I care about, because the function type is what we already know. It is going to be context is current context. So function type is just context function types. Ord map get name. Over here, I'm pretty sure that we can just unwrap because we did pre-process this function. So we have the body. And we have the function type. And this body is the AST. And what we need is to, you know, parse expression body. And this is the body, right? Oh, wait, I need the argument names. So I cannot, like, remove this completely, actually. I cannot remove this completely. Oh no. Fine, let's do this. Let's see, args is that. So I want arg names. Right? So we type ascribe name type, but we don't care about this. Arg names effect name. Maybe like we don't worry about the copy paste here for now. We just have the arg names and we have the body. This is going to be parsed expression. So we will context functions. We need to add the function named name. And the function definition. It has args, result type, and body, right? Function. Where function is args, result type, and body. So result type is function type result. By the way, when we are going to parse expression, we will do the type checking immediately, I guess. So we will say that the expression has the type of the function type result. Maybe it should not be called parse or whatever. So body is the expression, original type is that, and args is you know what? Let's just not say arg names. Let's say args. Fine, I'm just going to parse type here again. It's okay. Type is parse type. So we're just going to say args push back name and type, right? Is that the argument? Yeah, name and type is what we have there. We'll say that name is name. Expect identifier. So this args, this is the array list of function args, which is literally what we need over here. So what is remaining is just to parse an expression, right? So how do we parse an expression? Yeah, I need to rename these things. It's not parsing, is it? st expression and type of the expression should be the type name here. So we have type and we have the this thing, and we want to parse it. Okay. So we're going to match st shape. So what are the kinds of expressions that we need also, right? We need we need an identifier, basically. We're just going to make these strings. We need to apply a function, say then, say statement, expression. It also can be a literal. Right? Or should we not have literals, and like those would be constants anyway? Right? And then there is a native expression too. Native expression is the most complicated one, so let's ignore that. Rule. Expected an expression. if rule name is equal to statement then return statement parse expression. And by the way, so like for statement, we want the result type to be unit, which means that unit should be known. I feel like we need more in the type names, right? We need to know about what is a string, and we need to know about what is a unit. Still. So I want to parse statement where the type is unit. Statement, parse expression, a unit. Well, I mean, actually, this can be anything. But, I mean, it can be anything, but should it be anything is another question, right? How strict do we want this? Like in regular Kast, we can ignore currently the thing before the semicolon, like you do in other languages. But maybe for minicast, we want the type checking to be more strict. Like I need the type here. Unless we do the any. Oh, wait, we do need the any type, right? Yeah. But yeah, let's try to do the strict first. So in order to ignore things, we could make a dedicated expression ignore, for example. Or we're going to assign it to a variable which we don't use. Wait, but how do I implement ignore? It means that when I parse the expression, we like optionally know the type, right? Sometimes we don't know the type and we need to infer it. Well, like there is going to be inference, but it's going to be different than the Kast inference, right? So we either know the type or we don't know it. Actually, I think that makes sense, because we then, like, for example, when we have the expression, which is the identifier of a function that we know what it is, right? Then we already know the type. We don't, yes, but in some other cases, we are given the type here instead. Or something. Yeah. So we just parse expression, we don't know the type, and the AST is inner, right? So I'll just say over here that if no, we say that inner is root AST helpers expect single child with no name. Okay. I thought I had like a print single line. Did I not print single line? Oh, it is in the highlight. I see. I mean, I can depend on this. It's okay in my minicast. Expression got, you know, over here we can say highlight print single line AST. Yeah, just depend on the highlight. Expected type. Let's do this in other places too. Got highlight print single line AST. Top level item. Well, I mean, technically we have a span there, so it doesn't even matter, you know. But sure. Problem doesn't happen with 011, any of the most broken piece of software of all time. Right. Match branch must use the fence syntax because I did semicolon here for no reason. All right, so I mean, right now we're going to have the compilation error because we are going to try to parse expression, which is a statement, and inside of a statement we're going to have like the identifier, which we don't even care about, right? So if this is going to be like, yeah, we need to not do anything here. If it is a token, then we are going to have parse expression. Also, expression can be empty. By the way, technically, in this case, what do? We're going to have expression. What is the expression actually? We have span, we have shape. I guess the expression will have the type too. Right, so this is a type name. So we need something that returns a unit, right? So it's literally like a dedicated unit, I guess. So if it's empty, then we return shape is unit, type is unit, and the span is AST span. This over here also. Shape is statement, type is for statement type is unit. You know what? Yeah. How about we do this? Like, because I need to also check with this type. That's when we do the type checking, right? If it exists. So we probably want to say I don't know, let's call it ret, right? Which is a function which takes shape, and this basically returns shape, type, No, I know I need to do shape and type, right? Return type and shape. Maybe we don't do that actually. Return shape is this, type is unit, span is t-span. Maybe what I do instead is like, I need to just remember to check the type. How about we return? I mean, yeah, we always return the expression over here. So let me do this. Let result be this with return. So we're going to return to this place instead. Now I will say that result type, and this is the expected type, right? And over here we see we need like type check, expected type, result type, right? And then we return result. There we go. Boom, boom. I mean, maybe we don't do the span here, so that like we do it shorter. We say shape type is this, right? That's what I want to return. And then over here, so we expect the type, and over here we say shape type span is ast span. There we go. A little bit shorter. So over here I say type is unit. So we have a token. Okay, I'm going to match token shape. If it is an identifier, then we will return shape is identifier name. Type is... So since this is the identifier must be known, and for every variable that we have before, we should know the type, right? So the type would be find identifier type, identifier name. So find identifier type is a function name string. This returns type name. So like it is basically either a top level function or a local variable, right? Or a constant, I guess. Also, we make the distinction in minikast actually. So we say context is current context function. So we know the function types, right? So we say that if function types get name is some function type, then we return function type, right? Yeah, this is like a reference or whatever. Over here, before checking for functions, check local scope. We just don't have the scopes yet, I guess. And if we do not find it, then I need the diagnostic, right? You think getting Kast LSP to work with Neo Vim was enough of an achievement? I'll sleep now. Alright, good night, Nigel. Output is current output. I guess this also needs the span then. Span. Unless I give it like the token. It's okay, we'll give it like two things. Find identifier type, span is token span. And this identifier name. Sure. Diagnostic. Diagnostic will say that output right. Name not found in the current scope. Right? That's what we say. And we just have the span. Compiler error. Okay. So I should just be able to look up functions. The local scope, though, we should have the local scope. Let's see this scope. So we will have scope as a context, right? And scope is a context which has like parent, optional, scope, and it has variables, and for every variable we will know the type of it, right? So it's going to be an ORD map from string into type name. And that's all that we need, right? So the scopes only exist in the functions. That's the only place where we are finding the identifiers, right? So it's when I'm processing a function over here. Before I parse the expression, we know the arguments, right? So we are going to say that scope, we're going to say with scope context being equal to scope, right? Where scope is parent. We don't have any parent scope. We say that variables is ORD map new. And then we go for arg and args iterate. We say arg name scope variables. Add argument name, argument type, right? So now we know for every thing the type. Yeah, sure. Bum 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 bum. And now what? Now I can check the local scope too, right? So I say that scope is current find ident type. Yeah, just like find in scope, right? We say if find in scope So I'm trying to find in current scope, I'm trying to find the name, right? And if this is some result, then we just return the result here. There we go. And we say find in scope is scope. I guess I need a reference, right? And name is a string, and this returns the optional type name. Right? So what we do here, we're going to match scope vars get name. If we did find result, then we just return the result. If we did not find it in the current scope, then we need to go to the parent. So we need to go for scope parent. And if it is some parent, then we need to find in scope parent the same name. And if no parent, then we just return none. We have not found it, right? So now we can find the name in scope. We can look up the type of a variable. Find indent type. Okay. And the type check is the thing that is not present, right? So type check expected type is an optional. Well, I mean expected type. Let's make this to be a type name, and actual is also the type name. And in this span, so I say that if expected type is some expected type, then we're going to type check on AST span expected type. And for now, I think like if we don't count the aliases, then all I need to do is like to structural equality. So if they are not structurally equal, then we're going to do the error diagnostic. Where we say expected type print type name expected got actual we have unit, named, and function. Type name, we also have strings, right? Strings. Yeah. String. Strings. String. All right, let's look at the compilation errors if there's any. I think we're almost there. We are almost there. Making a couple more expressions. Couldn't find span and scope. Span. I feel like next time I will have something already working where we could do a hello world. Maybe. Ord map unwrap. This is option. args AST. args AST. args AST. args AST. Doesn't compile. Type is not type name. Parse type. Function arg. Oh, it's type. Wait, what? It's supposed to be type name. Type is the cast type, which maybe I can just shadow it and call the type name. Type name is probably just type. You know what? Type name is just type. There we go. Well, and to also print then. fine. Print is still going to be type name. Forgot comma here instead of semicolon. All right, that's a typo. Should probably make that to not be parsable. It was like supposed to be parsable previously, but now we don't want to. I could have seen a parser error here in my editor. None is a colon none also. Of course. Function type doesn't have field because function type is a reference. So we need to dereference the reference, of course. Option is type is not type. Yeah, because like the result of the function type, we know it, so we can type check this function with some result. There we go. Because parse expression expects an optional type. And do we know the type of expression that I'm parsing or not? Functions is not there. What do I call it? It's the program. Oh, it's, hold on, program functions. Okay. But that's my result, right? That's not like context. Context. State. Yeah, we have like function types and actual function definitions. We call it function definitions. Well, when I have the program, hold on, I have a program inside of the state, so we can start constructing it. There we go. So like we do context types, context program types, right? Like I'm adding the type directly to the types. And the functions should just be done the same. Context program functions, we just add the thing. There we go. Okay, expected expression got like this is useless. Yeah, this is not an expression because it's inside of the parentheses, of course, right? So let's make something that compiles, right? So we know that the types are processed properly, right? So the only thing that we can compile is a statement which has an identifier inside of it, right? So print hello world is not going to work, right? But we can say const main is a function that returns Unit. I think unit also should be like actually, because I have it hard coded, we will have it like this after all, I think. And so we will just say well, the only function that I have now is main, so we can just say main like this, and a semicolon. That's the only thing that we can do, right? I just cannot do a type which is a unit, so we need to still name it, but and we also cannot do the parentheses here. I'm gonna do this scope. All right. This thing opens a new scope, I guess. So I'm gonna do a semicolon there, because that's not how priorities work. Parse type. How about this? So if the ASD shape is empty, right, we will return the unit type. But if the over here, right, if rule name is equal to scope when we're parsing the type, then we are going to return parse type inner, where inner is root expect single child, which is not named, right? So this should parse the unit type, and like I can basically put the types in parentheses now also, if I want to. And when I parse expression, we say that if rule name is equal to scope, then I will say that with scope context is parent is some current scope, I guess, and vars is ord map new, and I would say inner is root except single child with no name, and we return shape is scope parse expression. We still have the same expected type as we had before, inner type, well, this is like the inner expression, which we parse. After we have parsed it, the type of the scope expression is the same as the inner expression, so it's just going to be inner type, right? Which also means that I need to have a new expression over here, shape, which is going to be called a scope, a scoped expression, right? We can say if rule scope is then but expressions is array list new statements, or something. We're going to... Right. Do you allow variable shadowing? Or is it just a typo? I do allow shadowing, yes. Do you not like shadowing? You like it a lot? It depends on the language. In some languages it's like very error prone. Like especially in a dynamically typed language, I guess. It is still an issue sometimes, but mostly I have not had many problems with that when using Rust. I have not had much problems with that when using a camel either. I think I remember having some issues with that in C++ back in the days, but I don't remember like the details. But I do think that like there should be still a switch to disable the shadowing. Not for the entire program, but like locally. Sometimes I could see how like you want to be really careful. Right, like you can exploit anything. Yeah. Yeah, the fact that something can be abused does not stop me from implementing a feature. Right, I have a lot of features that can be abused. I guess the extensible syntax is the biggest example of that. Right, like some people don't like operator overloading because it can be abused, and I have like even like next step of that, where I can have custom syntax, which can mean anything. Right. Speaking about the custom syntax, I feel like my so right now my LSP just shows the hovered character. I should be able to show the syntax node under the thing. Yeah. Also like the ranges, you can do the incremental selection, like based on the ASTs that can be implemented in the LSP. And I should. Statements. Right. It's not statements, right? Expressions. So we return then expressions, and the type is the last expression type, right? So we say first that last expression type is just equal to unit in case there are no things, although it's not supposed to be like that, right? Say for, I guess I just cannot have the yeah, whatever. We'll just start with unit. Now we say for expression in AST iterate list, root AST helpers expect. No, it's literally just root, or I mean it is literally just AST, the whole AST. We're going to iterate over the list where the binary rule name is equal to then trailing or leading rule name is not going to be there. With like statement is different semantics, right? So we do over here. By the way, I really like the fact that I have like this do keyword and the then keyword. I thought I would not like it, but I actually like it more than the absence of this keyword, because in case of the condition or like the loop expression itself to be multiple lines like this, this makes it more clear a little bit over here. Custom syntax is better than operator overload. Operator overload encourages cryptic syntax when you have to guess what a combination. Yeah. Yes. Like that's the whole idea, right? Like they really abuse it in languages like Haskell because they want to like write code in short, concise way, but because you use the random symbols, guessing what the symbol means is a lot more difficult than guessing what a word like return means, right? Imagine if return was like, I don't know, some symbol, some weird symbol. I don't know. Yeah. I definitely do think that they abuse it in Haskell. At the same time, like with custom syntax, you should be able to like understand what's happening easy, right? And like I was just talking about the LSP. LSP could like make you go to the definition of the syntax, go to the expansion of the syntax, so that you understand what the syntax means. If it's a custom syntax, right? We can do that. So we have the expression. In this case, the expression is going to be the AST, and we just say that expressions push back expression, but we need to convert it. Expression is parse expression. We don't know the type of it. Unless it's the last expression. Actually, hold on. How do I know that it's the last one? Oh no. When I do the iteration like this, I don't know. So let's, okay, fine. We'll do it in two ways then. So this is the list of ASTs. Let's call this expression ASTs. And then we will do another loop with expressions. So say expression in expression ASTs into iterator. Iterate. So now we are going to enumerate. Now we know the size of this basically is the main thing here. So we expressions push back expression. I will just say that expression. So expected type, right? Expected type is if I plus 1 is still less than length of expression ASTs, which means that I need to do the iter, not that. It's kind of like weird, like it's all messed up here with ownership. Actually, nothing is going to work once I actually have the ownership semantics. So if we have the next one, then it's going to be none. Otherwise, it is the expected type of the whole expression, right? And then we say that expression is parse expression. So this over here isn't going to be our reference now. Also parse expression, expected type expression. And we have a then. Statement, scope, a then. Yeah. This is enough. I think I'm going to stop here. This in general is easy. Like if we want to parse the application of the function, right? Then we will like look up the function. We will know the function name. We will know the function type. So we can figure out what are the arguments and everything. Yeah. It's pretty straightforward here. So maybe I could next time actually start on transpiling this to the target. And I think we will still start with JavaScript. So I don't need to worry about the types yet. Expect type unit, got this. Right. Because unit is not the type, right? Like now I need to actually specify this. And unit is not that. There we go. Unit is not found, so this is that. Okay, there we go. We actually have the main function, and it has been like parsed and type checked, it seems. So if I say main, for example, it's going to say expected unit, but got unit into unit. Right? So we actually have this stuff. Okay. Cool. Mini progress. I'm going to go and rest. Why is my internet all broken? I don't get it. I'll try to update my Linux, I guess, maybe. Like I cannot even push my I'm literally streaming and my internet doesn't work. Okay. Let me see on my phone. Who is there? Dun, dun. Dun, 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 dun. Alright, I'll just change it to lane again. Lane. Thank you guys for watching. See you next time. Bye.
They should coerce.